Okay, so we'd like to talk about this measuring the future of quantum and Japan's position and countdown to quantum supremacy. And we have three top sponsors, Qmix, Quantinuum, and also SQAI. Three companies are represented here in this panel discussion. And I would like to serve as MC. My name is Nakadoi. So, well, first of all, I would like to ask three of you to introduce yourself briefly. Yesterday on day one, you each had the presentations from your company, so maybe you can touch upon some of the contents that were referred to then. So, first, maybe can we ask you, Mr. Matsushita, to start off? Thank you. Hello, my name is Matsushita. I am CEO and president of Qmix. So we were established 6 years ago in 2019. We are a venture company in the quantum computing algorithm development. And ever since we were founded, we really focus on FTQC purpose algorithm because we always believe that the algorithm should be developed for that because FTQC is the ultimate one. At the time, we didn't have the term even early FTQC, but despite of that, we have been working on the development of the algorithm for FTQC, especially for CAE, quantum chemistry calculations, and machine learning. And we wanted to really always develop the algorithm development that will be really can be a standard or de facto standard for these three sectors. And then we have been working with many industry leaders, and we have been trying to find the solutions using the power of the quantum computing to solve their problem, to solve the social problems. And today, in the afternoon, we will have the opportunity to make a presentation about the results of the joint research we've done with Honda. So please come to the use case, the case study session to listen to our presentation. And so the kind of algorithm we've been developing for these three segments includes, for example, well, when it comes to FTQC, we really wanted to make sure the algorithm is really feasible. And in order to prove it, we have to really be able to run it as soon as possible on the actual computer. And so the machine is actually provided by Quantinuum. The ion-trapped type quantum computing is the earliest possible really available computer. So that's why we are actually using Quantinuum machines to prove, and we have been actually proving that our algorithm actually works. Thank you. So, since the name was already mentioned, Mr. Kekke, please. Hello, thank you. My name is Kekke. I'm the representative of the Japan branch, the subsidiary of Quantinuum. I talked about this a little bit yesterday, but we are a global leader, one of the global leaders in quantum technology in US, in UK. We have roots in both countries because of the merger. The UK company, which used to develop the algorithm, which was a spin-off from the university, was joined with the quantum computing department from Honeywell, which was also made into another company, and these two companies were joined together. And now we have 550 plus employees across 8 offices, and we actually have more than 30 people in Japan who are working on the research. And so we have more than 400 researchers, and we have 145 plus global patents. And if you include the patents being pending, then actually we have the IP of more than 500. And we actually have the capabilities full stack. We have been working very aggressively with many companies in collaborative efforts. Just as Mr. Shimada said earlier, collaboration is a key at this point of time. And we have 500 people in the company, but still we cannot solve all the problems alone, many problems actually. So we have established teams for a specific topic, and then each team works with specific and appropriate teams from around the world, from universities, from industry, and to carry out our research activities. Finally, so as you see here, we have the full stack capabilities. If you see at the top, these are the applications. So these are the capabilities that will be used in different industries like chemistry purpose applications, optimization purpose applications. So we are working on them. But at the same time, in order to run them, at the bottom you see the hardware layer, and then there is middleware layers, programming languages. We are developing all of them, and some of them are actually made open source. But at the same time, we are using the application languages or software from other companies. We actually provide the compatibility with them, and that is actually one of our goals. You see, the ecosystem partners are listed for applications. It's not only our application. We do use Quemix's applications, for example, like Pyte. Their own algorithm is used in developing our applications too. And we have a great momentum to support great applications, great algorithms. And also we have the ecosystem of hardware. You see the word that mentions here at the bottom. So we want to be agnostic of the hardware because depending on the type of the research people want to conduct, the appropriate hardware changes. And so we want to make sure that the users can find efficient and appropriate process by making our technology agnostics to the type of the hardware. So next is the Professor Okubo from Tokyo University and also from SQAI. Hello, my name is Okubo. I'm from the University of Tokyo and also from SQAI. And as you can see here, I've been always working on the basic research, especially for quantum physics. And in 2020, I started to work on the quantum since 2012, sorry, when I started to work on tensor. And now I've been working on quantum algorithm. So I don't really work directly with the industry people, but I would like to really support the industry from this aspect of the physics, quantum physics. And so I would like to touch upon SQAI very briefly. This is the Center for Innovation for Sustainable Quantum AI. And so our goal is to develop such systems. And we have been receiving support from COI Next project on quantum software for the past 10 years. As Professor Todo talked about it yesterday, you see on the right words, and these are the areas that I personally have been developed. For example, tensor network and quantum circuits. The translation between the two is realized to support the sustainable quantum AI. That's one of my missions. And also supercomputer or HPC and quantum computing hybrid. That is something we are trying to work on. This is one of the very focus areas in Japan.
Thank you very much. Now, without further ado, we would like to start having this discussion on the themes. First, this is Q2B Tokyo. This is the event that strive to make quantum a viable business. So I'd like to ask each one of the panelists where they stand in terms of this topic. So starting with Mr. Kekke. It is the foreign affiliated company in Japan. So what is the attractiveness of Japanese market to non-Japanese companies? Thank you. In January 2019, we started our operation in Japan. This is the 6th year. In the beginning, annealing was the mainstream in quantum computing. And commercialization back then was focusing on communication as well as annealing. So gate type quantum computing was a challenge for us to take on. We believe that would take time, but this is the topic that we thought we should work on. As you know, it did take some time, but explosive calculation capacity of quantum computing is one of the attractiveness. So companies who participate in Q-Star and government people have given us a wonderful understanding. So we have very good business environment. Universities, company researchers, we are actually forming a very flexible network with them. Thank you. Quantinuum actually deliver actual devices to RIKEN. So they are already in operation? It is correct. So starting on February 1st this year, thanks to the support and subsidy of NIDO, Fugaku supercomputer, quantum supercomputer hybrid project started. As part of that, we delivered our devices to Wako campus of RIKEN. Many researchers have already used that device. The hybrid environment, it requires more than simply connecting to the internet. It is a high-performing environment. Beyond supercomputer performance, there are multiple challenges we have been able to identify since then. Especially, I believe this is the area where Japan can lead the whole world. So we are very anxious to achieve more, excited. So starting with Professor Okubo, you talked about the Industrial Alliance. You said you are on the academia side. So from that perspective, if you look at where Japan stands as a research hub, what is the attractiveness that Japan can offer? The uniqueness of Japan is hard to explain. As Mr. Kekke explained, though, SQAI is working on high-performance computing connected with quantum computing. And that's where Japan can lead the whole world. Professor Inoki, RIKEN made a wonderful presentation yesterday. Tensor network and also supercomputer can be combined together. Quantum computing can be combined together. And I think we are a little bit ahead of other countries in this area. Thank you. Qemix, our company, as I said, have worked with multiple companies working on quantum computer. Now, Matsushita, can you also make a comment where Japan stands in terms of quantum computing? HPC and quantum computer are now blended together in a hybrid format. If I make a comment on that, HPC and quantum computer hybrid system, I believe is very useful in solving real practical problems. It's a very realistic solution. We'll be able to achieve this quantum supremacy and advantage early on with this technology. And of course, our wish is to commercialize that technology as soon as possible. Applying quantum computing to the best possible target, that will be in manufacturing. In Japan, manufacturing is the strength of the country, and there are many companies who are faced with challenges in manufacturing. This hybrid computing system and algorithm, if we are able to develop them, will be able to invigorate Japanese economy. And I believe that the quantum computing industry then will rise and succeed because of that. So they are interchangeable in the meanings. Because Japan is a manufacturing-based country, it has very strong manufacturing industry. There are a lot of applications of quantum computing. So the next question is when? What's the timing? I believe everyone in the audience is interested in when this is possible. When quantum exceeds classical computing. So from the applications perspective, when the hardware becomes ready, that will be the condition. Kekke-san, when? I think it's a very difficult question, but I think it's a very important question as well. As we engage in research activities, in the industry, there are some groups of companies that are committed. They have clear schedule. It's like rhythm section as a jazz band. Drummers and bass players, they actually set the rhythm. Then you also have flexibility in development at the same time. Now, in order to achieve quantum supremacy, the time frame depends on this rhythm. Setting the minimum condition, minimum line. In that sense, quantum volume, well, we set the target for 5 years, and we want to continue to achieve that target every year during those 5 years. But in a way, the research team is very much constrained. They have to deliver that target every year for the coming 5 years, but they were able to do that for the past 5 years. And this is the future roadmap up to 2029. And the researchers that are involved in this activity, they will have to be focused on this target. They have to deliver this target. That is a responsibility of this group. And Mr. Matsushita and other people are working on algorithm development, and they are, of course, providing us support. So 2029, Apollo, that would be more than 100 logical qubits. It's a very ambitious roadmap. Yes, including error correction technology. We have a separate roadmap for error correction technology. It's not just surface coding that is the mainstream today. We have many other error correction codes that are actually progressing day by day. So in terms of error rate, as you can see, there is a wide range of forecasts. The latest research, if that is enabled and realized, we may be able to go beyond that. So we want to set aside on a future goal that is even more ambitious than this. So, Professor Okubo, this is an interesting paper that you announced last year. Can you talk about this? Thank you. The quantum computing exceeding classical computation. So this quantum supremacy, when is this going to happen? We are using supercomputer and tensor network and also surface coding. We actually did the research. We made the announcement in 2024. Beside the targets we set, if you look at the consolidating matter of physical, we believe this is the area where this quantum supremacy may come earlier. And the specification that hold the key is indicated here. Logical qubit will be 100 or more. And T-gate that is necessary for logical qubit target, the operations has to be 10 to the 8th power up to 10 to the 9th power. And logical error rate that is necessary, considering a surface coding, you have to multiply inverted number with coefficient, so that will be 10 to the minus 11th up to 10 to the minus 12th power. So that will be close to the upper limit of error rate. And we believe it is possible to achieve that by 2029. Thank you. Matsushita-san. from early on, we talked about quantum supremacy, possibly achievable in 5 years. And the members of our companies are nodding. So what is your comment? At this point in time, if you look at the technologies that are available today and consider what will happen in 5 years, it will be difficult with current technologies in terms of hardware and software or algorithm. We need to develop further to achieve supremacy in 5 years. But every year, if you look at the same algorithm, the depth of circuits that is necessary has become shallower and shallower. In other words, we have more efficient circuits. The gate operation numbers have been minimized due to various technologies that are developed. So considering our experiences in the past, you can extrapolate the future development. So considering that it's not just quantum computation in 5 years, CAE, machine learning, they will present positive possibilities. So Professor Okubo talked about the currently available technologies, this slide, but algorithm will evolve further. And I believe certainty will increase. So within 5 years, we set the target to achieve the supremacy. So hardware, software, and theory as well. We're hoping to see the realization of the quantum supremacy in Japan. I have prepared a lot of other questions, but I think we exceeded our time already. So with that, we would like to conclude our session here. Thank you for listening.